Hello, let's continue our Sudoku adventure with MicroSIM by Stuart Sharpe. So this actually looks like a SIM card. That's pretty neat. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have region sum lines in the grid, like this big blue line here. It's actually a loop, but that's okay. It's a line. And this line here. How these lines work is when they cross a box border, they become a new segment. So this is a segment, this is a segment, this is a segment, this is a segment, etc. Just whenever they cross a box border, it forms a new segment to the line. So a line is made up of 2 or more segments usually. One segment wouldn't work. It would be a nothing line. Anyway, so this line is 2 segments. This line's a bunch. Anyway, within an individual line, the sum of each segment is the same. So whatever these 4 sum to, it's the same as these 2, and it's just the same as these 3, which is the same as these 2, etc. So, but then this could sum to something different. These 2 sum to this guy. And then finally, we have these 2 squares in the grid. These are even digits. So they're 2, 4, 6. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. We've got some min-maxing to do, I think. I'm just gonna put 2, 4, 6 here so I don't forget about them. But the shortest segment on this loop is 2 cells, and the longest segment is 4 cells. So we're limited by that, right? 4 cells can be 1, 2, 3, 4 at minimum, so that's 10. 2 cells can be 5, 6 at maximum, which is 11. So our sum is already 10 or 11, which means for these 4 cells, we're either going to be 1, 2, 3, 4 for 10 or 1, 2, 3, 5 for 11. It's the only way we're going to do that. If you want to know how to kind of think about that in your head in a nice way without just trying to like case check, is we know 1, 2, 3, 4 is the smallest it can possibly be, and that's 10. In order to increase the sum to 11, one of these digits has to increase by 1. That's the only way to do it. But we can't increase a digit whose slot is already used up, right? So like the 1 can't increase to 2 because we already have a 2. The 2 can't increase to 3 because we already have a 3, etc. So the only digit we can increase is the 4, and so we end up with 1, 2, 3, 5. So we know that this always contains 1, 2, 3, and it's from 1, 2, 3, 4, 5, so there's a 6 in one of these two, which does put a 6 up here. And so now this is either going to be 4, 6 or 5, 6, meaning there's a 6 in one of these 2 cells. Is there another 2-celler? Yeah, right here. So this is the same. And so this can't be a 6, and this can't be a 6. All right. So there's a 6 down here somewhere, one of these 2. So these add to 10 or 11 without a 6. So the way to think about whether that's interesting or not is what is the biggest we can get without a 6? Well, it's going to be 3, 4, 5. And that adds to 4 times 3, which is 12. So that's 1 over our max. We add to 10 or 11. So if we added to 11, we'd have to do 2, 4, 5. We have to subtract 1 from one of them. If we add to 10, we could do 1, 4, 5. Or we could do 2, 3, 5. But I think that means it always has a 5 in it. Yeah, so if we omit the 5, 2, 3, 4 adds to 9, which is too small. So there is always a 5 in it. And look what that does. That points over here, telling us we can't have a 5 over here, meaning it's 4 plus 6, making it a 10. So this is also 4 plus 6, and then this is just 1, 2, 3, 4, which we can write out, and this is 5, 6. Perfect. So there's a 5 up here also. Now we add to 10. So we can't put both the 5 and the 6 over here. That already adds to 11. And so this cell has to be the other 5, 6 that isn't on this line. So the other 2, which includes this guy, either adds to 5 or 4. But we don't know exactly how that goes. 4, 6 pair does put a 2 here. All right, 4, 6 pair puts a 2 there. So these are the odd digits, 1, 3, 5. So are these, 1, 3, 5. So how are we working this? These are only odd digits. 2 odd digits add to an even digit. So this has to be 6. And that leaves us with 1, 5 over here. That's our 3. That's a 5. And that's a 6. That cannot be 1 or 3. This is 2 or... this can't be a 4 because the 4, 6 pair. So that's 2 and that's 4. All right, this is cleaning up nicely. That cannot be 5. Right, in fact, this is 1 or 3. So we have a 1, 3 pair here, meaning we need a 4 in the column, which goes there. And this is a 1 or a 3. All right, that was a nice Now we know these need to add to 10. 5 plus 2 is 7, so this better be 3. That's 1. That's 1. We get over here, the 1. All right, what do I want to do here? We know these add to 10. So is there more I want to do? With, let's see, the line or... All right, one's one of these two. 2 and 3 are up here. 5 is down here. 5, 6, 1 and 4 are here. 1's down here. 4 is down here. I don't know if that's helpful. Okay, I don't think this can be 4. Because if it went with the 6, we'd already be 10. Remember, one of these has to be a 5 or a 6. So if we got a 4 here, with the 6, we'd already be 10, which is too big. You know, we'd have a third cell to fill. And then 4 plus 5 is 9, which means we'd have to put a 1 on the line, but the line can't have a 1 on it because of this one and this one. So we cannot put a 4 here, and that does mean this is a 1-4 pair. So this is 2 or 3. So we can do another case check here, I suppose. Do we want to case check it, or is there something simpler? This is 5, 6. Oh, so this has both 2 3s on it. If you think about it, this 2 3 needs to end up here, but it can't be where this 5 6 is, and this 2 3 ends up exactly right there. So 2 plus 3 is 5, meaning we need to put a 5 with it. So this is from 2 3 5, and this is a 6. Okay. Now, what do we do with this? We need a 4. And that goes on the line. So we know the line has a 4 on it. So these 3, the 2 that aren't the 4, add to 10 minus 4, which is 6. So we can do 1 plus 5 or 2 plus 4. Well, we can't do 2 plus 4 because the 4 is already... The 4 isn't part of the 6, right? The 4 is on its own. And then we need 2 more digits that add to 6. We can't repeat the 4. So it's only going to be 1 5, which means that we can place the 2 and 3. But let's just mark this out. So, sorry, not like that. We have the 4 here, the 5 down here, and this has to be the 1 then, because these can't be 1s. So we need 1 4 5 is my point. This is the only place for 1. This is the only place for 5. This is the only place for 4. Okay, that's 4 and 1. That's 6 and 4. That's 6 and 4. That's 3 and 5. That's 2, 3 and 5. 3 in the corner. 2 and 3. All right, we get the 2 and 3 here. Last digit's a 6, and we're done. Very nice. All right, cool puzzle, Stuart. I enjoyed that. Nice use of the region sum line here. I liked the min-maxing, and I actually liked how this forced the... there's probably a way to think about this row a bit holistically. Let's think about this, because I kind of... I brute forced it a little bit, but if you think about it, these two, like this sum and this sum, if you add them together, they sum to... an even number. And in fact, we knew that they would add to either 5 plus 5 or 6 plus 6. Sorry, not, what am I talking about? They were sum to 10 or 11. So 10 plus 10 or 11 plus 11. 11 plus 11 would be 22. And we know that the entire row sums to 21. So that wouldn't be any good. This would be a negative 1. So we know that these both sum to 10, leaving a 1 behind. So I could have done that a little bit cleaner maybe. But yeah, and then same deal here, maybe? Well, it's interesting that it left a 1 behind, but no, these can't do the same thing. Okay, anyway, let me know how you did on this one. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.